Welcome all. This is the first question. It says, at what effective annual rate of interest I, the present value of 100 due at time 5 plus the present value of 200 due at time 15 is equal to the present value of 300 due at time 10. This is a simple question. This is 0. Timeline is very important here. And the present value of 100 due at time 5. So let me divide. This is 5. This is 10. And then this is 15. The present value of 100 due at time 5. We'll find the present value of 100 plus the present value of 200 at time 15. 200 at time 15 is equal to present value of 300 due at time 10. Okay. So this should be equal to present value of 300. So what is the equation here? How can you form an equation? So the present value of 100 you need to find, and the present value of 200 you need to find. That should be equal to the present value of 300 at time 10. This is the question. Okay. You find the present value here. So 1 plus 3 should be equal to 2. That is what we are doing here. This value should be equal to this plus this, right? So what is the equation here? X is v power 5, and you put here, you will get 100x plus 200 x power 3 is equal to 300 x power 5. Now when x is equal to half, v5 is equal to half. Okay. And when x is 1, v5 is equal to 1. This is 1 upon 1 plus I power 5. So this is also 1. 1 plus 1 upon I power 5. That is equal to 1 upon 2. So this 5 is here. If you take, it will be like this. Okay. So this power 5 is here. That I have taken this side. If you solve this one, I will be 0. Okay. So this will give you an I which is 0. So we don't want this one anyway. Let's solve this one. So around 15%, that is our answer. So I is 14.8% approximately. This is the solution. The other one, if you see, I will be 0. We are not interested here. 0% interest rate. Now let's go to the next problem. The question is, find the effective rate of interest per annum for which the amount which should double in 6 years. If deposited in a bank now, if you deposit in a bank, it should double in 6 years. What is that interest rate? Yes, I'd like to hear from your side. What is that interest rate for which if you deposit an amount, suppose you want to deposit 5,000, that will double in 6 years. You want to get double amount in 6 years. Suppose you join a course, 6-year course, and they say you have to pay 50,000 at the end of 6 years. You want to deposit some amount now. Okay, suppose you have 25,000 now. You are wondering whether that amount will grow to 50,000 in 6 years or not. So at what interest rate you need to deposit so that the amount 25,000 will grow to 50,000? If you deposit A, that should grow to this one. But as per the question, it should be 2A. In the question it says, if you deposit A, this should grow to 2A in 6 years. But if you apply the formula, you get this. That is the difference. Okay, if you apply the formula, you get this. So according to the question, this amount should be equal to this amount. Then whatever amount you deposit, that will double after 6 years. I can modify the question for you. Instead of giving this one, I'll give you an interest rate. Okay, I will say you deposited some amount here. It will take some times to double. Okay, you deposited any amount, it doesn't matter. You don't know that time. Interest rate is given 8% per annum. And normally now if you deposit, you will get 6% per annum. It's very less, okay? 5-6%. Even US, it's not less than 1%. Suppose 6% per annum interest rate you get from the bank. What is the time when your money will double? This is the question. So what I did is here, I've given you the interest rate and you want to withdraw the money when your money will double. Or you are wondering after how many years, if you keep in the bank, your money will double. That is what you want to know. So here in that case, you apply the same formula. After t years, it will be a multiplied by 1 plus I power 6. So you can write this way, a multiplied by 1 plus I power 6, that should be equal to twice of a. And then if you continue to solve this equation and cancel a from both the sides, you will get 1 plus I power t is equal to a. Because time is not given here. We don't know that time. We want to find t. Okay. That is equal to 2. Here you have to take log. Again, remember, after 10th class, whenever you take log, remember we take log base e. It's not base 10. You can take base 10 also. It doesn't matter. In this case, I'm saying, but normally in calculus, log is, base is always e. So when you write this one, t will come here. T log 1.06 is equal to log 2. So t should be equal to log 2 divided by log 1.6. Here it will work for any base, okay? It doesn't matter. You can take base 10 also because we have taken log both the sides. But normally we take base e only. It will take almost 12 years. This is the question. I here in 1 plus I, you can write 1 plus I4 divided by 4. Power 4. Because I4 is given directly, why not use here? Okay. If you find I also, that's fine. You have to put it here once again. We don't know I anyway. So why to write that? Power 4 minus 1 is there. Power minus 4. You need to save time. Okay. This will be 1 plus I4 by 4. Power 4. Here 5 minus 20. If you are not comfortable this way, then you can find I from here. Not a problem. I4 by 4 power 4 minus 40. Okay. That is 1000. You put here I4 12 and you solve this equation. That's all.